Number one, it says name the following ionic compounds and specify the charge of any transition metal cation. Well, if you look, all of these are transition metals, so they all have to have a Roman numeral. And so let's talk about how to figure out that Roman numeral. So, number one, A. Number 1A is going to be iron, something, iodide. If it wasn't a transition metal, we wouldn't have to work, we just call it iron iodide. Okay? But since it's a transition metal, it can have multiple oxidation numbers or multiple charges. So we have to figure out what that charge is. An easy way to do it is just draw dot diagrams. How many I's do we have here? Two. We know that iodine is in group 17, so iodine is going to have 7 dots. So I'm going to draw 2 iodines with 7 dots. So how many dots does this iodine need to become chemically stable? 1. And this one also needs 1. So the iron, since there's only 1 iron, has to have 2 dots, 1 to give to each iodine. And so this is going to be iron 2 iodide.
So you only add the prefix if it's covalent, right?
Right.
Okay.
Right.
Is that just a coincidence that the subscript is 2?
Yeah.
Okay.
Yep. Now it'll work out sometimes like that. Okay, and we'll show you.
But you don't like look at it.
No, you
like,
don't.
that's
Don't look at the
not-
subscript. Okay. And we'll get to this last one here. You'll see why. So the next one, Mn's manganese. So this is going to be manganese. Something. What is it? Fluoride. And so we have 3 fluorines. So let's draw the dot diagram for all 3 fluorines. They're in group 17 again, so they've got 7 valence electrons. So how many electrons does manganese need to give these 3 fluorines? 3. So it's real easy. So it's going to give 1 there, 1 there, 1 there. So this is going to be manganese 3 fluoride. Again, it's just a coincidence here because that's not always going to work out. Letter C, chromium, something, chloride. Now you can just leave it plugged in and come sit up here. So you can see, right? Alright, whatever. So chlorine is in group 17 also, so it has 7 dots. How many do we have? 2. So what's the number on chromium going to be?
2.
Do I need to draw the dot diagrams?
No.
Okay. So it's chromium 2 chloride. Letter D, copper something sulfide. Sulfur's in group 16, so it has how many dots?
6.
6. So 1, 2, 3, 4, 5, 6. We only have 1 sulfur. So how many dots does copper have to have?
2.
2. Okay, so Cu. So this is going to be copper 2 sulfide. So you can't always look at the subscript, right? And that's the reason. That's one reason why. Does that make sense? Kind of. Does that help a little bit?
Yes.
Okay. So number 2, it says find the charge of the cadmium cation and cadmium bromide. Explain your reasoning. So I'm going to explain my reasoning with a dot diagram. So bromine, we have 2 of them. They all have 7 electrons because they're in group 17. Do this. So cadmium has to have how many electrons? 2. So what's the charge of the cadmium when it loses those 2?
Plus 2.
Plus 2. So this is my explanation, and the charge is plus 2. Okay? And then number 3, I think covalent compounds are really easy to name and write the formula for, which I think you'll find as we go through this. So SCO2, if the first element only has 1, we don't put a prefix on it. That's the only time a covalent compound does not get a prefix, is if it's the first one and there's 1. So this is going to be selenium. There's 2 oxygens, so it's going to be dioxide. On letter B, Si is silicone. There's only 1 of them. Oops. And there's 4 iodines, so
Tetraiodine?
tetraiodide. I don't know, I probably should leave that A off of there, I'm not sure.
Wait, I'm pretty sure it's the A because it auto-corrected me whenever I
Oh, it
left
did?
the A off,
Okay.
so I'm pretty sure it's.
Because I know you'll leave it off on oxygen, so sometimes, but if you leave it in there and it's wrong, I'm not gonna count it wrong for spelling, okay? I don't really care about that. Letter C, now we have 2 arsenics, so that's gonna be di, arsenic, and 5 oxygens, so penta, oxide, and then D, 4 phosphoruses. That's kind of hard to say. Yeah.
What's the word on C?
Diarsenic pentaoxide.
Oh.
Okay? So this would be tetra, phosphorus, tri, sulfide. Okay, and then it's really easy to go from the names to the formulas. Di means 2, penta means 5, so that means we have 2 arsenics and 5 oxides, and so on.
For sulfur, can it be like sulfate too?
Sulfate is different, okay? Sulfate is this. It's a polyatomic ion, SO4 2-. Okay, so change the ending to IDE. Okay, if there's a different ending than IDE, it's not. It's a polyatomic ion is what it is. All right. So I'm going to erase this and let's look at the worksheet. So you don't have the worksheet out, get it out. Let's start on the side that says Section 2 Review. I have this someplace. Here it is. And let's go over this real quick. Number 1 says, would an atom of sodium and an atom of potassium join to form an ionic compound? No. The reason why both have a positive charge. You know anything about magnets, opposites attract, right? Positives attract to negative. 2 positives would repel each other. Number 2, why are electrons shared equal in oxygen but not in carbon dioxide? In O2, each O wants the electrons equally. But in CO, the O wants the electron more than C.
Mr. Bodenhausen,
Yeah,
do you have Kinsey McGinnis?
yes,
She needs to come check out, please.
okay.
Thank you.
So on that, here's this we do tomorrow. On the thing in the book, it's at the end of the section, okay? There's also a quiz for you to take, so make sure you take the quiz. Number 3 is really easy. If there's 1 line, it means there's 1 electron being shared, 2 lines is 2. So number of shared electrons, this is 2, this is 1, so this is double, this is single. You can read my writing. And then number 4, which of the bonds in calcium hydroxide are ionic and which are covalent? I'm going to move this up. So Ca bonded to OH is ionic. But within the OH, the O bonded to the H is covalent. Because the OH is a polyatomic ion. All right? So the Ca to the OH is ionic, but the O to the H within the OH is covalent. All right? So we have both sharing of electrons and transfer of electrons all happening together. So flip this over.
Dollar computer.
Yeah. Forget something? Number 1, we're dealing with ionic bonds. So the first question for CaBr2 is Ca a transition metal?
Yes. No.
No, it's in group 2, so it's not a transition metal. So we just name this, we don't have to put a Roman numeral, we just call it, it's really easy, calcium bromide. And then they want you to put the charge. Calcium's in group 2, so what's the charge?
Positive.
Positive what? 2. Bromine's in group 17, so what's its charge?
Negative.
-1. Then down here for nickel, let's go ahead and do the charges for this. Nickel 2, so it's going to be Ni plus 2. And then oxygen's in group 16, so what's its charge going to be? -2. So to find out the formula, we need to draw the dot diagrams. Okay? You probably can figure it out here because you know the charge has to be equal. Okay? So +2 cancels out -2. So it's just going to be NiO. But let's look at it in terms of dot diagrams. The Ni has 2 dots. The O has 6 dots. So these 2 dots are going to come down here. And the nickel's got rid of all of its electrons. The oxygen is full. So we've got 1 nickel, 1 oxygen, it's just going to be NiO. All right? So a couple of different ways to think about that. For cadmium nitride, this is going to be a little bit more complicated. So cadmium has 2 electrons, right? Nitrogen has 5. So, yeah, I do it like that. So if cadmium gives up its 2 electrons, this cadmium is stable, but the nitrogen still needs 1 more electron, right? So we need another cadmium. So let's write another CD, draw the 2 dots. So now the nitrogen's stable, but is the cadmium? No, it still has an electron. So let's draw another nitrogen. So if we get rid of that 1 electron, now the cadmium's stable. Is the nitrogen? No, so we need to make another cadmium. Now these 2 electrons would come over here. What's the formula going to be?
N2
CD3N2.
Right, you can't put the N first. You always put the middle first. Okay, so it's going to be CD. You have 3 CDs and 2 N's. Okay, metal always goes first. And then for number 2, these are covalent, so these are easy. So Si is silicone, so this is going to be silicone. Tetra is it iodine, so tetra iodide. Dinitrogen monoxide is going to be what formula? How many N's are we going to have?
2.
2, and then how many O's? 1. And then P4O10 would be tetraphosphorus, deca, oxide. And then number 3, what's the charge of the cadmium ion and cadmium bromide? Well, let's draw the dots. So bromine has 7 dots because it's in group 17. We've got 2 of them. So that means the cadmium has to give up 2 electrons for that to be stable. And so it's +2. My explanation is right there. Any questions? All right, on Canvas, there's a quiz for you to take over naming compounds and formulas. While you're taking that quiz, I'm going to give you this worksheet. You can go and get started on it, but I'm going to help you. When everybody's done with the quiz, I'll help you more with it, okay? So I think this worksheet is called bonding and naming. Is it naming worksheet 1? Is that? Yeah, okay. So this is naming worksheet 1. It should be the only one opened up for you. Okay?
Oh wait, the one that we just did or that one?
No, this one.
I think that's bonding and naming worksheet.
Bonding.
Bonding, it's bonding and naming worksheet.
This one was naming worksheet.
Okay.